Okay, children, so we didn't get to this problem in class, so I've decided to make a little video of it, and you can watch this to help you with problem numbers 67 and 68 on the homework. So here's a maximization minimization problem. These are very common types of problems that involve polynomials. So let's say I use material that comes in rectangles measuring 40 centimeters by 30 centimeters, and I want to cut out square corners from this rectangle in order to fold the material into an open-faced box. And if I wanted to maximize the volume of the box, what size of squares should I cut out? So first, let's just look at a potential rectangle for you here. Okay, and let's just say that this is 30 by 40 centimeters, right? And here's 30, and here is 40, okay? So if I cut out little squares here, all right, and each of these squares was x. It's a square, so obviously this side and this side are equal to each other. And I cut these out, so then I could fold this side up. I could fold it along this crease here. And I could fold it along this crease here. And I could fold it along this crease here. And I could fold it along this crease here. And I'd have a little open-faced box. Okay? So like this will be gone, and that will be gone. So I'm cutting them out. And that will be gone, and that will be gone. Okay, so then I'm going to have like a little box, and so I'll just do a little perspective drawing here. All right, yeah, I'm pretty artistic, don't you think? Okay, so there's my box, there's my open face box. So now we need to think about what the dimensions of this box are so that we could find the volume of it. Well, so this dimension, this is the long side. And since we removed an x here and we removed an x here, this is going to measure 40 centimeters minus 2x. And then this side of the box, this side right here, since we removed an x and an x, this side is going to measure 30 minus 2x. And then the height is going to be x, right? So the volume of this box is going to be, and I'm going to say the volume with respect to x, which means, or sorry, the volume as a function of x. So the volume will depend on the size of the sides of the square that we cut out of each corner. Okay, so to find the volume of a box, you find the area of the base, which is 40 minus 2x times 30 minus 2x times the height. The area of the base times the height. It's a prism. Okay, area of the base times the height. So this is a polynomial, isn't it? Okay. And we can kind of see where the zeros are going to be there, right? Okay. So you can start thinking about what a reasonable domain would be, like what x values make sense. So this I just want you to think about on your own, and you can pause the videotape and think about it for a second. The maximum x value is obviously it's going to be at least, you know, it's going to be 30 or less than 30. It's got to be less than 30, okay? In fact, it's got to be less than 15. Because if x were 15, then we wouldn't have, we would cut all of this out here. This is 30. If x were 15 and 15 and 15 and 15, we would just remove one part of the box, and that wouldn't be a very good use of material. So x cannot exceed 15. You know, x probably isn't going to be 0, but maybe just a little bit over that. So our domain, our relevant domain, I'll put RD, is going to be from 0 to 15. And I'm not going to include either of those things. Okay, So our relevant domain is that there. Make sure that you understand that, okay? So now what I'm going to do is I am going to, I could think about this graph a little bit. What I want to find is the maximum volume of the box. So is volume our X value or our Y value? Correct. It is our Y value. That is the volume. And what we want is for this number to be a maximum. Okay. So you might want to think about this just because we've been talking about polynomials. So we have, this is going to be what degree of polynomial? It's going to be cubic. And it's going to be positive because we have a negative times a negative times a positive, which is going to give us a positive. So this is going to be the degree. All right. This should make sense because volume is a three-dimensional measurement. Okay. So all that should make sense. Positive, we're going to have the end behavior is going to be up on the right and down on the left. Okay, outstanding. So in order for you to find your maximum, you're going to use your calculator here, okay? And I guess I'll move it there. And I'm going to put this equation into my calculator. I'm going to look for a maximum. So I have x times 40 minus 2x parentheses 30 minus 2x. Okay, I'm going to graph this. I'm pretty sure I know what's going to happen. I'm pretty sure I'm not going to see it in my window. And that's okay. I'm just going to have to adjust my window. You, of course, are not going to be tempted by Zoom Fit. Okay? But the first thing I think I want to start with in my window is as a reasonable domain. So my domain was 0 to 15. I'm gonna open it up a little bit just so I can give some room to see it on both sides. Okay? So I expanded to 17. My Y max is probably going to have to be pretty big. Let's just imagine what 40 times 30 is. That's 1200, and then another X out there. So I'm going to go with 2000 and see where that gets me. Okay, I'm going to graph it and see if I can get the top of that. I'm close. We're going to see it come down over here. So I'm going to increase my Y maximum to 4000 and see if that's a little better. See what it looks like. There it is. We're going to get the maximum in there now. So this is the value that we're interested in right there. We want to find what X value is going to give us that maximum Y value. So you guys, I think you know how to do this. So we go second calc, and then we want to find a maximum. We enter. And then we have the spider grab the left-hand side. This is more arduous than I'd like it to be. And then we have the spider grab the right-hand side. Okay, and then we have the spider guess that high point there. Okay, and so notice, and I'm going to drag this over here. I'm going to drag this over here. There it is. Okay, so there is our picture. And what we know is, let's go back to our question for a moment. What should the sides of the squares measure in order to maximize volume of the box? So we're looking for our X value. And our X value is 5.66. X is about 5.66, and we should put units there, centimeters. And when we remove that, the maximum volume will be about 3032 centimeters cubed.